Hello and welcome back to another video. In this video we did past papers for moles, and I also did some empirical and molecular formula. I covered the questions from the year 2023 and 2024, all the variants. I hope this video helps you. If you have any question, you don't hesitate to ask. This question is about the compounds of tin. Tin 5 oxide has the formula of SnO2. The relative formula mass is 151. Calculate the percentage by mass of tin and SnO2. Alright, so percentage by mass is going to be the mass of tin, which is 118.71. 118.71 divided by total MR, 151 multiplied by 100. The answer is 78.8%. Next, this question is about sulfuric acid. A dilute sulfuric acid and aqueous sodium hydroxide, so you have dilute sulfuric acid and aqueous sodium hydroxide, can be used to prepare sodium sulfate. A method that involves titration. The parameters for titration is shown as in the figure. Okay. 25 centimeter cube of aqueous sodium hydroxide NaOH of concentration 0.1 mole decimeter cube, so that is mentioned here in the beaker, is neutralized by 20 centimeter cube of dilute sulfuric acid, which is in the burette. Now, the equation for the reaction is shown, which is this one. Calculate the concentration of sulfuric acid using the following steps. Calculate the number of moles of NaOH. Okay, moles equals concentration times volume. What is the concentration? It is 0.1 mole per decimeter cube. Volume is 25 centimeter cube. Convert this into decimeter cube. 2.5 times 10 power negative 3 moles. Determine the moles of sulfuric acid that react with NaOH. Let's write the ratio between them. NaOH. This is 1 sulfuric acid reacts with 2 NaOH. That is going to be 2.5 times 10 power negative 3 x. It's going to be 2.5 times 10 power negative 3 divided by 2, and we get 1.25 times 10 power negative 3 moles. Calculate the concentration of sulfuric acid. So concentration is going to be moles divided by volume. We know the moles of sulfuric acid, which is 1.25 times 10 power negative 3 divided by volume. What is the volume of sulfuric acid? 20 centimeter cube. 20 divided by 1000 to convert this into decimeter cube or liters, and we get 6.25 times 10 power negative 2. Potassium hydrogen sulfate KHSO4 can be prepared by reaction between aqueous potassium hydroxide. Okay, so we have KOH and dilute sulfuric acid plus H2SO4. Water is the only other product. Write a simple reaction. So what is the salt that's produced? It's KHSO4, and everything is balanced. Okay, letter F. 0.325 gram of zinc is added to a dilute sulfuric acid which contains 0.1 mole of sulfuric acid. The equation for the reaction is shown, and determine whether zinc or sulfuric acid is the limiting reagent. Okay, so we need to find the moles of sulfuric acid that is formed when this much zinc reacts, and we have to compare, is it more? Does this produce more than 0.1 or not? We have to see whether the moles of sulfuric acid which are present, are they more, or the moles which are produced in the reaction is more. So moles of H2SO4 present is 0.1 moles. Moles of sulfuric acid that reacted. Moles of zinc is going to be mass over MR. 0.325 divided by MR of zinc. What is the MR of zinc? Let's see from the periodic table. 65.39. This is going to be 5 times 10 power negative 3 mole. 1:1 ratio Now, which one is more? Moles of sulfuric acid that is present is more. So there was more sulfuric acid. That shows zinc is limiting. Then 0.01. Alright, moving on. In another experiment, 48 centimeter cube of hydrogen gas is produced. This experiment is carried out at room temperature and pressure. Calculate the number of molecules of hydrogen gas at room temperature and pressure. The value of Avogadro's constant is 6.02 times 10 power 23. Okay, so they're saying that we have 48 centimeter cube of hydrogen gas and calculate the number of molecules. 1 mole has how many molecules? 6.02 times 10 power 23. So first we need to find the mole so that we can find our molecules. Let's find the moles of hydrogen gas. Is going to be volume divided by 24 liters, 48 divided by 1000, all divided by 24. This gives us 0.002 moles. So if we have 0.002 moles, how many molecules would that be? Just multiply 0.002 with the Avogadro's constant times 10 power 23. The answer is going to be 1.2 times 10 power 21 molecules. Okay, an incomplete symbol equation for the preparation of ammonia is shown. Complete the symbol equation. Calcium oxide plus ammonium chloride gives us calcium chloride plus ammonia. We get water. This is balanced. Name NH4Cl. This is ammonium chloride. Alright, calculate the volume of ammonia, NH3, measured at room temperature and pressure, which forms when 1.2 gram of CaO is heated with excess of an ammonium chloride. So they're saying, calculate the volume of ammonia. What is the ratio between CaO and NH3? It's going to be 1 to 2. We need to find the volume of ammonia. So let's find the moles first. What is the moles of CaO? Mass over mR. 1.12 divided by mR is 56. We get 0.02. So mole is 0.02. This is going to be 0.04 times 2. Now, we can find the volume of ammonia. Remember, moles equals volume divided by 24. So moles times 24 is going to give us the volume. This is 0.96 decimeter cube. The answer is supposed to be in centimeter cube, so multiply by 1000 and you get 960 centimeter cube. Alright. Nickel sulfate crystals contain water of crystallization, as you can see here. When nickel sulfate crystals are heated, they give off water and nickel sulfate. A student carries out an experiment to determine the value of X in NiSO4.XH2O in hydrated nickel sulfate. What are the steps? First, nickel sulfate crystals are weighed, then they're heated. The remaining solid is allowed to cool and is then weighed. The remaining solid is heated again, allowed to cool, and is then reweighed. Step 4 is repeated until there is no change in mass. State the term used to describe crystals that contain water, that is called hydrated. State why. Step 4 is repeated until there is no change in mass. Why are they heating and cooling and then weighing? Why are they doing that? Because we want to make sure all of the water is removed. Okay, in an experiment, 0.454 grams of nickel sulfate crystals is used. The mass of anhydrous nickel sulfate, NiSO4, remaining is 0.31 grams. So we have the MR. Determine the value of X. Use the following steps. First, calculate the number of moles of NiSO4 remaining. Moles is going to be mass divided by MR. They told us the mass is 0.310. 0.310 0.310 divided by MR is 155. That is going to be 0.002 moles. Calculate the mass of H2O given off. To do that, we can just subtract both masses, because we know hydrated minus anhydrous is going to give us the mass of water, 0.144 grams. Calculate the moles of water given off. Mass is 0.144 divided by MR is 18 here, so it would be 0.008. Now calculate the value of X. We know the moles of NiSO4. We know the moles of water. So now we know the moles, but we don't know the ratio. We have to find the ratio. Water. Moles of water is 0.008 and moles of NiSO4 is 0.002. So X is the ratio for water to 1. This is going to be 0.008 divided by 0.002. That is 4. So it's going to be NiSO4.4H2O. This question is about sulfuric acid and salts that are made from sulfuric acid. Okay. Zinc reacts with dilute sulfuric acid. Zinc and dilute sulfuric acid react. Aqueous zinc sulfate is one of the products. Powdered zinc is added to dilute sulfuric acid. The mixture is stirred. More zinc is added with stirring until zinc is in excess. The mixture is then filtered. Name the limiting reagent. So they're saying they keep on adding zinc until there is no more reaction. So obviously H2SO4 will be the limiting reagent. I included this question for the molecular and the empirical formula. Ester Y has this structural formula. Name the alcohol and the carboxylic acid used to make ester Y. To do that, we have to read from C11O. This is the carboxylic acid. We have methanoic acid, and then the remaining is going to be the alcohol. So count the carbon, 1, 2, 3. And the alcohol is on the first carbon, so we'll say propane 1-ol. State the molecular formula. C, H, and O. What is the number of carbons? 1, 2, 3, 4 carbons actually. 4 carbons, 8 hydrogen, and 2 oxygen. Now next, ester C has the molecular formula C4H8O2. State the empirical formula. We can divide this by 2, so we'll get C2H4 and O. Moving on. Table 2.2 shows the relative abundance of 2 naturally occurring isotopes of copper. Calculate the relative atomic mass of copper to 1 decimal place. Alright, so that is going to be 63 multiplied by 70 divided by 100 plus 65 times 30 divided by 100. You basically just multiply 63 by 70% and 65 times 30%. And the answer is going to be 63.6. Letter C. Manganese 5 oxide is added to 20 centimeter cube of aqueous hydrogen peroxide. Okay, so we had hydrogen peroxide and a manganese oxide was added to it. The total volume of oxygen produced is 72 centimeter cube at RTP. Calculate the concentration of aqueous hydrogen peroxide in gram per decimeter cube using the following steps. First, calculate the number of moles of oxygen gas produced. So moles is for gases is volume in liters divided by 24. So what is the volume of oxygen? It's 72. 72 divided by 1000 to convert it into decimeter cube divided by 24, and we get 0.003 moles. Next, determine the moles of hydrogen peroxide which reacts. So what is the ratio between H2O2 and oxygen? Since we know the moles of oxygen, it would be 2 to 1, 0.003 to X, and we get 0.006. Next, calculate the concentration of aqueous hydrogen peroxide in moles per decimeter cube. So what is the formula for concentration? It is moles divided by volume. Moles are 0.006 divided by volume of peroxide, it's 20. So divide by 20 divided by 1000 to convert it into liters, and we get 0.3 moles per decimeter cube. Now calculate the concentration of aqueous hydrogen peroxide. Again, same thing, but in gram per decimeter cube. To do that, just multiply this by mR. So concentration in gram per decimeter cube is going to be concentration in moles per decimeter cube times mR. What is the mR? If you add the ARs of H2O2, you will get 34. So it's going to be 0.3 multiplied by 34. The answer is 10.2 gram per decimeter cube. Alright, moving on. Table 2.1 shows the relative masses and percentage abundances of two isotopes of boron. Calculate the relative atomic mass of boron to one decimal place. Just 10 times 20% plus 11 times 80%, and we get 10.8. The equation for the decomposition of aqueous hydrogen peroxide is shown. This is aqueous hydrogen peroxide. This is decomposing into water and oxygen. 50 centimeter cube of 0.2 mole decimeter cube of H2O2 is used. Calculate the mass of oxygen that forms using the following steps. First, calculate the moles of H2O2 used. So using this information, we can find the moles. Moles equals concentration multiplied by volume. 50 divided by 1000 multiplied by 0.2. This is 0.01 moles. Calculate the moles of oxygen produced. The ratio is 2 to 1, 0.01, and this is x. So x is going to be 0.01 divided by 2. We get 0.005. Finally, calculate the mass of oxygen produced. Moles is going to be mass divided by mR. Mass is going to be moles, which is 0.005 into mR is 16 plus 16. We get 0.16 grams. Table 2.3 shows the relative abundance of two naturally occurring isotopes of bromine. These are the isotopes and their abundances are shown. Calculate the relative atomic mass of bromine to one decimal place. Very simple. 79 times 55% plus 81 times 45%. This is percentage basically means divide by 100. I'll just write it to make it more clear. Plus 81 times 45 divided by 100, 79.9 or one decimal place. Okay, next, in titration, 25 centimeter cube of 0.08 moles aqueous potassium hydroxide, this one, is neutralized by 20 centimeter cube of dilute sulfuric acid, and we get potassium sulfate and water. Calculate the concentration of sulfuric acid in gram per decimeter cube using the following steps. First, calculate the moles of KOH used. Remember, moles in terms of concentration is going to be concentration multiplied by volume. So we use these values. 0.08 multiplied by 25 divided by 100, and we get 0.002 moles. Determine the moles of H2SO4. The ratio is between KOH and H2SO4 is 2 to 1. If this is 0.002, what it is going to be? We'll just divide this by 2 and we get 0.001. Finally, next, calculate the concentration of H2SO4 in mole per decimeter cube. So concentration is moles divided by volume, 0.001. What is the volume of sulfuric acid? It's 20 centimeter cube. 20 divided by 1000, 0.05 moles per decimeter cube. Now in gram per decimeter cube. So just like the previous step, concentration in gram per decimeter cube is mR. multiplied by concentration in moles per decimeter cube. So you can find the MR from the periodic table, and we get 98. 98 multiplied by concentration 0.05. The answer is going to be 4.9 gram per decimeter cube. Table 2.1 shows the relative masses and percentage abundances of magnesium, two isotopes of magnesium. Calculate the relative atomic mass. Just multiply 24 times 85 divided by 100, or 85%, plus 26 times 15 divided by 100, and you get 24.3. That is the AR. Now, the equation for the reaction is shown. Zinc plus sulfuric acid, and we get zinc sulfate and hydrogen gas. 25 centimeter cube of 2 mole H2SO4 is added to excess zinc. Calculate the volume of hydrogen gas formed at room temperature and pressure. The volume of 1 mole of any gas is 24. Use the following steps. First, calculate the moles of sulfuric acid used. So we can find mole concentration times volume. Concentration is 2 multiplied by 25 divided by 1000. This is going to give you 0.05. Deduce the moles of hydrogen produced. So the ratio is 1 to 1. So if this is 0.05, that is also going to be 0.05. Calculate the volume of hydrogen formed at RTP. Moles is volume over 24. So volume is going to be moles times 24. Moles are 0.05 multiplied by 24, and we get 1.2 decimeter cube. Okay, hydrated zinc sulfate gives off water when it's heated. It's giving water. A student does an experiment to determine the value of X in hydrated zinc sulfate. These are the steps, and student weighs a sample, then he heats the sample of hydrated zinc, then he weighs the solid after heating, and then he repeats steps 2 and 3 until the mass of the heating is constant. So he heats and then weighs, heats and weighs. Why does he do that? To make sure all of the water is removed. Next, in an experiment, 0.574 grams of hydrated zinc sulfate is heated until the mass is constant. The mass of zinc sulfate that remains is 0.322. The MR is given. Determine the value of X using the following steps. Calculate the moles of zinc sulfate remaining. Okay, so moles is mass divided by MR. Mass is remaining is 0.322 divided by MR is 161. That would give us 0.002 moles. Calculate the mass of water given off. To find the mass of water given off, you just have to subtract it, right? 0.574 minus 0.322. This gives us 0.252 grams. Calculate the moles of water given off. Mole is mass over MR. What is mass is 0.252, and MR is given here, it's 18. 0.014 moles. Next, determine the value of X. We know the moles of water and we know the moles of zinc sulfate. We basically have to find the ratio between the two, okay? What are the moles? 0.002 to 0.014. This is 1 zinc sulfate, so the ratio here is 1 to X. The answer is 7. Okay, many organic compounds contain carbon and hydrogen only. An organic compound has the following composition by mass of carbon and hydrogen. Calculate the empirical formula. To calculate the empirical formula, you have to find the moles. Okay, moles is mass over MR. The mass is not given, but the percentage composition by mass is given. So it's going to be 83.33 divided by MR, which is 12, to the ratio of 16.67 divided by 1. So what is the ratio? It's 6.94 to 16.67. Now you have to divide this by smallest number, which is 6.94. you get the ratio 1 to 2.4. Now you can't write 1 and H 2.4, right? Let's multiply this by 10 and we get 10 to 24, 5 to 12 when we have divided this by 2. So we get C5H12. That's the empirical formula. Okay. Compound B has the empirical formula of C2H5 and the relative molecular mass of 58. Determine the molecular formula. Okay, first we have to find the multiplier. This is going to be 58 divided by MR of empirical formula. What is the MR here? 12 plus 12 plus 5 into 1. This is 29, okay? So divide 58 by 29, we get 2. This is the multiplier. 2 times C2H5 is going to give us C4H10, okay? C4H10 is the molecular formula. Okay? Deduce the empirical formula of this ester. So what is the molecular formula first? We have C, 1, 2, 3, 4, C4. What about H? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 hydrogen. What about oxygen? 1, 2 oxygen. Divide this by 2. What do here? So we will get C2H4NO. Next is, that's another question, okay? State the mass of 6.02 times 10 power 23 atoms of S34. Include units in your answer. The answer is going to be 34 grams because S34 represents the mass of 1 mole. And they're asking the mass of 6.02 times 10 power 23 atoms. This is also 1 mole. Hydrated cobalt sulfate produces water when it is heated. Okay, so this is heated and we get cobalt sulfate and water. Student does an experiment to determine the value of X. So first he or she weighs the sample of the hydrated sulfate, then heats it and then weighs it again. Describe what else a student should do to ensure that water has been given off, no other substances are required. Okay, so he's supposed to repeat steps 2 and 3 until you get a constant reading, because every time you heat it again, more water is removed. So you have to heat it until all the water is removed. Alright, so in an experiment, 1.405 grams of hydrated cobalt sulfate is heated until all the water is given off. The mass of cobalt sulfate is given, that is 0.775 mR is given. Determine the value of X using the following steps. So first of all, calculate the moles of COSO4 that remain. Moles is going to be mass over mR, 0.005 moles. Alright, now we're supposed to calculate the mass of water given off. To do that, we just have to subtract the mass of hydrated and anhydrous. So it's going to be 1.405 grams minus 0.775 and you get 0.63 grams. Next, calculate the moles of water given off. So moles is going to be mass divided by mR. 0.63 divided by 18, which gives us 0.035 moles. Now determine the value of X. Alright, so we have the moles, this is the equation. We have the moles of cobalt sulfate, we have the moles of water. We need to find the ratio to find X. Moles are 0.035 and 0.005, 005. Write 1 here and X here. So it's going to be, X is going to be 0.035 divided by 0.005, that is 7. Now, the relative abundance of thallium 203 and 205 is in the ratio 3 to 7. Calculate the relative atomic mass of thallium in the sample to 1 decimal place. Okay, so it's going to be 203 times 3 divided by 7 plus 3, which is 10, and then plus 205 times 7 divided by 10, that is 204.4. Make sure it's 1 decimal place. Okay, Next question, and this is probably decomposition of magnesium nitrate, gives us magnesium oxide and nitrogen dioxide and oxygen. So this is not mole, we'll start from here. Calculate the volume of NO2 at RTP formed when 7.4 gram of magnesium nitrate is heated. Use the following steps. Calculate the MR of MgNO3. So using your periodic table, you will just add the ARs, and that is going to be 148. Calculate the moles of magnesium nitrate. Moles is going to be mass divided by MR. Mass is 7.4 divided by 148. The MR gives you 0.05 moles. Determine the number of moles of NO2 formed. So the ratio between NO2 and Mg and magnesium nitrate is here 2 to 4. This is X and this is 0.05. So X is going to be 4 times 0.05 divided by 2. This gives you 0.1 moles. Calculate the volume of NO2 gas in centimeter cube. So remember, moles is volume by 24. So volume is moles times 24. Moles are 0.1 multiplied by 24. Convert this into centimeter cube. So multiply this by 1000 and you get 2400 centimeter cube. Okay. Organic compounds contain hydrogen atoms. Calculate the number of hydrogen atoms in 44 grams of ester methylpropanoate. 1 mole contains 6.02 times 10 power 23. Give your answer in standard form. Okay, so we need to calculate the number of hydrogen atoms. To do that, first we need to find the moles. Moles is going to be mass divided by MR. Mass is 44 grams. What about MR? Add it here to find MR. 12 plus 3 plus 12 plus 2 plus 12 plus 16 plus 16 plus 12 plus 3. This gives you 88. So 44 divided by 88 is going to be 0.5 moles. Okay, so we have 0.5 moles of CH3, CH2, COO, CH3. Now we know in 1 mole how many molecules we have. We have 6.02 times 10 power 23 molecules of this ester, right? So if we have 0.5 moles, how much is that going to be? 3.01 times 10 power 23. But the question says calculate the number of hydrogen atoms. So how many hydrogen atoms are in one ester? Let's count. We have 1, 2, 3, 4, 5, 6, 7, 8. So 3.01 times 10 power 23. Multiply this by 8 and you get 2.408 times 10 power 24 hydrogen atoms. Next question. Silver bromide AgBr is made when aqueous silver ethanoate is added to aqueous sodium bromide. The equation is shown and we get these products. The method includes the following steps. First, add 200 centimeter cube of 0.05 silver ethanoate to a beaker. The volume contains 0.01 mole of Ag plus ions. Add 50 centimeter cube of aqueous NaBr. This volume contains 0.01 moles of Br minus ion, a precipitate forms. Alright, so they're telling us we have a beaker, and in beaker we are adding 200 centimeter cube and 0.05 mole per decimeter cube of CH3COOAg, silver ethanoate. This volume contains 0.01 mole of Ag plus ions. Like there is silver, right? This is the amount of moles in this volume. Okay, in this beaker we are adding 50 centimeter cube of aqueous sodium bromide, and this volume has 0.01 mole of Br minus ions. So they're both allowed to react, and then filter the mixture, dry the solid residue, record the mass of the dry residue, complete the ionic equation. So in this equation, basically silver ions and bromide ions are reacting to give us silver bromide. This is a solid, so it's going to be filtered out. Now this is not moles, this is moles. Use the information in step 2 to calculate the concentration of aqueous NaBr. Okay, NaBr. We know the moles and we know the volume, so we can calculate the concentration. Concentration equals moles per volume. Moles is 0.01 divided by 50. 0.01 divided by 50. We need to convert this into decimeter cube, divide by 1000, and we get 0.2 moles per decimeter cube. Now use the information in step 1 and step 2, like these two steps, and equation 1, this is our equation, to determine the number of moles of AgBr formed. Use this value to calculate the mass of silver bromide formed. Alright, first let's find the moles of AgBr, silver bromide. So we can do a ratio method. We can do AgBr with let's do NaBr. The ratio is 1 to 1, so this is 0.01, that is also going to be 0.01. So moles are 0.01. What about mass? Moles is mass divided by mR, so mass is going to be moles into mR. 0.01, the mR is 188, and we get 1.88 grams. Calculate the mR. The mR is not given in the question, so you need to calculate it from the periodic table, adding the ARs.